This device is what's known as a Van de Graaff generator, and it's capable of producing tens of thousands, if not hundreds of thousands of volts. And what it does is creates these charges on the outside of the surface of the dome here. And once we turn this on and create a charge around the outside here, we can discharge it using an earth. So this is actually what is known as an earth. And why? Because it carries the charge from here down, literally through here, through the cord here, down to the earth. So we'll turn this on and see how it works. So there you can see the discharge. As I said, tens of thousands, perhaps hundreds of thousands of volts. And what's that related to is the weather. If we had a wet day or a humid day today, we would not see this, and I would not be electrocuted the way in which I am being electrocuted at the moment. So I'll just discharge this and give you an idea of how it works. So to put this charge on the dome, what's needed is, where the process starts, is down here, and I'll just show you the underneath surface here. Now you should be able to see there a piece of metal, aluminium, and that aluminium is in contact with a belt. Now the cord here can feed in electrons if it's going to charge this with negative charge. Those electrons are picked up by the metal here and carried up by this belt. Now when they get to the top of the belt and inside the dome, I'll just show you what's inside here. You can see a similar sort of piece of aluminium, and that is in contact with the belt. So what can happen then is that the electrons can be carried onto the aluminium here, and from there get to this piece of metal, and from there to the inside of the dome first of all, and from the inside of the dome electrons are going to be pushed to the outside. Now why do they end up on the outside? They end up there because electrons are going to repel each other. They're pushed out onto the outside of the surface, and what that really then means is, for a moment, we have no potential difference between the metal here and the metal here. So when the next lot of electrons arrive, okay, there's no problem in those electrons flowing to the inside and then pushing more electrons to the outside. The charge then builds up and up and up as the belt continues to bring up the electrons. I'll just put this back on now, and we'll see some of the effects that can be generated using our Van de Graaff generator. The first thing I'll do is put a horsehair, or it's really not horsehair, it's actually some cotton or wool, and we'll turn the Van de Graaff generator on. And what you can see there, of course, is the pieces of wool all spreading out. They're pushed apart because they're all carrying the same charge, electrical charge. And if I bring this close to here and discharge it, okay, they go to sleep. And if I take the earth away, they wake up again. this around. I hope I don't get electrocuted, but you can see there's a difference in the charge carried by the earth here and what's on the electroscope. So the pieces of cotton or wool are attracted to the earth. Now, another device which we can use on our Van de Graaff generator is the container here, which has a number of styrofoam spheres. At the top here we have metal, and underneath here we have metal, and here we have a connection that can go to the dome. And as the charge builds up, the electrons then become spread onto the metal surface in here. The styrofoam balls pick up charge and then start repelling each other. Now I have here a set of aluminium pie dishes, and I'm going to put those aluminium pie dishes on top of the dome here, and we'll see what happens. So you saw what happened. Now the interesting question, of course, is why? Now, one of the fun things that girls, especially girls with long hair, love to do is put their hand here and turn the machine on and see what happens to their hair. So I'll give that a try and just show you how simple it is. Now, one of the things that you need for this exercise actually is hair. Now, one of the things that happened just then was I did get an electric shock. It didn't kill me. And one of the reasons is that the current is quite small. So look, it's a good fun machine, but it also has practical uses. One of the uses is in what is called particle accelerators. So with the electric field that surrounds a dome like this, if you've got a method of having positive or negative charges here, they can be forced in a vacuum to go at very, very high speeds towards a target, and they can fire that, for example, electrons at metal and generate X-rays, and those X-rays can be used for various purposes. The other use for Van de Graaff generators is in particle accelerators. So in a particle accelerator, this dome would be surrounded by a vacuum, would be inside another container. And without the air there, the potential difference that can be generated is much, much higher. And then these charged particles can be accelerated and then fired at other particles in what are called atom smashers. And as a result of the collisions that occur and the breakup of the protons, electrons, protons, neutrons and so on, they can find out information about subatomic particles. So it's quite an interesting little machine.